What if you could see every device on your network with just one command? Cisco's CDP protocol reveals all your connected routers, switches, and more. But did you know it's also a hacker's dream? In this video, I'll show you how to use CDP like a pro, plus reveal the SNMP secrets that network admins use to monitor their entire infrastructure. Stay until the end to learn the shocking security risk most companies overlook with SNMP. CDP, Cisco Discovery Protocol. CDP helps us create maps of our network. It is important to have a complete view of your network to simplify our lives, whether in management or troubleshooting. CDP runs on all Cisco devices. It helps us to detect and identify the equipment in our network. It is a Cisco proprietary protocol, which works on the data link layer and is enabled by default. On our topology, we have three routers, R1, R2, and R3. Let's admit that we have no idea what our network will look like. We'll try to find out with CDP. The Show CDP Neighbors command allows you to see the neighbors that are directly connected to the router. On router 1, we can see that it is connected to router 2. We even see that it's a 3640 router, as well as the interfaces on both sides. On router 2, we can see that it has two neighbors, R1 and R3, and on router 3, its neighbor is router 2. We can see that the link between router 2 and router 3 is a serial link. The Show CDP Neighbors Detail command allows us to reveal even more information. For example, here we can see the IP address and the version of iOS. This can be of great benefit to us, but it is also a security risk. So, by default, CDP is enabled and runs on all interfaces. If you want to disable it on one interface, you will use the No CDP Enable command directly on the interface in question. And if we want to disable CDP on all interfaces, then we will do a No CDP run in global configuration mode. And that's it for CDP. SNMP, Simple Network Management Protocol. SNMP allows administrators to manage network devices and diagnose problems very quickly. It works with a monitoring server and agents that correspond to the equipment that administrators want to supervise. It can be switches, routers, firewall, PCs, or even different services of the equipment. The supervisory information is stored in a database, which is called the MIB. Any device that is SNMP compatible can be supervised. We will see how the set of elements that communicate in SNMP is composed. A network device, whether it is a router, a switch, or a firewall, runs an SNMP agent in the background, which is actually a daemon process that will respond to network requests. This SNMP agent provides a large number of object identifiers, which are called OIDs. These are universal identifiers, which are represented by a series of numbers. For example, here is the OID of a Cisco 2950 switch to read its temperature. Thanks to this OID, it will be possible to configure alerts in the event of exceeding a certain degree threshold that has been defined. And here's one last example. An OID can be long and complicated to decipher. That's why it's stored in a MIB, so that it's more readable for us humans. The objective of these OIDs is to allow compatibility with different supervision software. And the objective of the SNMP is to identify the resources to be supervised. The SNMP protocol is used by many management applications to monitor the status of network devices, and all this with a beautiful graphical interface, which gives better visibility. To secure this data, it is possible to authorize or not access to these OIDs with an SNMP authentication system. So, You don't necessarily need a MIB to use SNMP or to make requests on network devices. But without it, it will be difficult to understand the data that the devices are returning. Some information is easy to understand, such as the name of the host, the disk usage on a PC, or the port status of a switch. But in other cases, a MIB can help much better with understanding. Most devices use the public community name as authentication, which is not secure. SNMP can be used in two different ways, or in polling, or by trapdoors. Polling is the process of sending a query at regular intervals to get a particular value. This active verification technique allows a program or script to check whether the data returned is correct. And the traps consist of doing passive verification. That is to say, we can configure a network device, such as a router, to send an SNMP trap when there is a particular event. For example, the router can send a hatch when it detects a broken link on one of these interfaces. And it is even possible to configure an email notification when the SNMP trap is sent. There are 3 versions of the SNMP protocol. The V1 remains the most used version because it is the lightest. The V2 is a version that has been abandoned because it is too complex. And V3 allows you to have the advantages of version 2 without presenting the disadvantages. In conclusion, SNMP is an indispensable tool in a network environment as it allows administrators to detect problems very quickly. We will now move on to the configuration. In version 1 of SNMP, we first create an access list to authorize only our supervision server. Here, the ACL number is 1. Then we define its community with the command SNMP server community. In the example, the community is called training. The RO that we see just after stands for single reader. That is to say, the supervision server will only be able to query our equipment. He will not be able to order him to turn off. For example, after the RO, we place our ACL number. The SNMP server host command allows us to define the address of our monitoring server. And don't forget to specify the community. And finally, all that remains is to activate the hatches so that the equipment sends to our server any change of state. To do this, you need to run the command SNMP server enable traps. SNMP version 2 is the most widely used version today. This is exactly the 2C version. The commands are the same, except that in the SNMP server host, we must specify the 2C version. And finally, let's move on to the SNMP configuration in version 3. Here, you must first configure the SNMP v3 group. Next, configure the monitoring server. And configure the identification of this same server. With the SNMP server group command, it is specified a community called training, followed by version 3. Then we choose the type of authentication among the 3 available modes. Come after the MIB access mode. It is either read or write, and the V1 default is an unrestricted function because if desired, it is possible to give read or write access to certain MIBs. Then we need to configure a login password for our supervision server. With the SNMP server user command, we specify a connection name. Here we have chosen the name Centeron, followed by the training community. Then we tag the V3 to have the choice of authentication here in MD5, and we put the login password of the supervision server. And all that remains is to identify the monitoring server with the SNMP server host command.